Okay, so this is part 2 dimension analysis. So like where we ended, we are actually talking about fundamental physical quantities. We are those quantities that we can use to derive other quantities, which we are calling derived quantities. So in this part of the video, we're actually going to focus on this. So this is the main part of dimension analysis. Okay, so the first quantity that we are going to understand is I'm going to talk about area. How can we get the dimension analysis for area? Okay, so we know that area is given by a length squared. Okay, when you multiply length times length, or I know for you guys, you were taught that if you have a rectangle, the area is going to be given by L multiplied by B. All these are just dimensions for length, because the breadth and the length are all length, so it's more like L times B is just length squared. So how can we get the dimensions for area? You know that length, the dimension for length is just capital letter L, which we put in brackets. So how can we find now the dimension for length? We are going to find that the dimension for length is just going to be equal to L squared, because we have this squared. So with that information in our mind, now it's very simple for us now to go and understand the dimensions for velocity. So before I talk about the dimension of velocity, I can also talk about the units of length. So how can we now find the units for length? We know that the units for length is meters. What about the units for area? We know that it's length squared. So while there is L, we are going to put M. So we say M, because we have this squared, we say meter squared. That's why you used to say that area is measured in cubic meters. I mean square meters. How can we find the velocity? By definition, you know that velocity is the rate of change of distance over time. So this is the formula for velocity, but we know that the distance here is just length. Okay, so we are going to replace this by the units, or by the dimension of what? Of length. So where there is distance, we replace the dimension for length, which is just L. Then what is time? The dimension for time, if you can go back here, you are going to appreciate that this is just capital letter T in square brackets. So we say over time. So this is the dimension for velocity, L over T. But you can express this in the other way, because there's another way which you can find this and you get confused. I know if you can go back to law of indices, we were taught that if you have 1 over A is same as A to the power negative 1. Okay, so whatever is in the denominator, if you want to take it on the numerator, we can change we just need to change the sign of the exponent. If it is negative, it's going to become positive, and vice versa. So what we are going to do, we are going to take this T on top. That is just the rule of indices. So we are going to say that velocity is now going to be equal to, on the numerator we already have L. Now T here is in the denominator. For us to take it on top, the sign of the exponent, or of the power there, is just going to change. We know that it has a silent one there, so it's going to be negative 1. You should take note of that. So this is now going to be the dimension for velocity. I know by now velocity is just the same as speed. The only difference is that velocity is a vector quantity and the speed is the scalar quantity. And you understand now to say speed is given as meters per second. Where do they get these units? Okay, it's because we know that if we want to get the units for velocity, what we are going to do is that we know that length here is measured in meters. So we're going to say the units are going to be meters. What about time? Is in seconds. We say over seconds. So this is where they get these units. So the units for velocity is meters per second. Or we can take this s on top. We remove it from the denominator. So it's going to become, where there is L, we put M for meters. And where there is time, we put S for second. Then you put the -1. These are the parts that you should need to focus on very, very careful. So the other parts which we can talk about is acceleration. So acceleration, I'm going to say acceleration is defined as the rate of change of velocity over time. So it's just the velocity over time. Okay, of which we already know to say that velocity, if you want to find out the dimensions for velocity, how can you find the dimension for velocity? We know that the dimension for velocity is given as this or this. You can choose anyone you are familiar with. So I'll go with this. So I'm going to say the dimension for velocity is actually, or in this case, let me use this one, is L over T. Now we are dividing by time. The dimension for time is T. So how can we find the dimension for acceleration? So when we are dividing, we know that when we are dividing there, we say L over T there. So we are going to change the sign from division to multiplication, but we have to reciprocate this dimension for time. So it's going to be 1 over T there. Okay, so if you have to multiply out, you're going to say L multiplied by 1. We are going to get L. Then we are going to get T multiplied by T is just T squared. So this is the dimension for acceleration. If you want to write in this form, you can write it as L will still remain like this because it is on top. Now to take T on top there, since it is positive of T squared, it's going to be T to the power -2. How can we find the unit for acceleration? Because most of you were just told that acceleration is measured in meter per second square. You didn't know where it was coming from. So that's where dimension analysis comes into effect there. So how we find it? We know that L here is measured in meters and time in seconds. But we know that time is squared, so even second is squared. This is where the unit's coming from. Or you can write in this form L, M, then T, we have S, then to the power -2. So you should take note of this. So I'm going to answer the last question. Then I'm going to give you an assignment that you're going to answer. Then you're going to drop the answer. So what we are going to do here, we are going to now find the dimensions of force. Okay, I think I gave the formula in the first lesson to say that force is given as mass times acceleration, of which the dimensions for mass, the dimension for mass is just capital letter M in square brackets, and the dimension for acceleration is the one which we are from finding to say it is given by L, then T to the power -2. So I can just replace the given values to find the dimensions. So mass is capital letter M, and acceleration you just multiply by this. So this is how you find the dimensions for force. I think I can add on also another important thing that I've just remembered is frequency. I think this is going to be the last one. Okay, how can we find the formula for the formula for the dimension for frequency. First of all, let me finish with force. I didn't give the units. How do we find the units for force? Because we know that mass, the unit for mass is kg. The units for length is meters, and the units for time is seconds. Now let's to the power -2. So these are units for force. These are very important, guys. In an exam, you're going to meet this question in test, quizzes, and exams. So what else do we need to know about frequency? Frequency is given if it is frequency is just the number of oscillations taken per second. So in this case, frequency is just the reciprocal or the inverse of time or the inverse of period. So frequency is given by 1 over period. I know most of you know this. So the dimension is just going to be 1 over, where there is time, you put the dimension for time. So that's why we're going to take this. We can take this on top. It's going to be g to the power -1 because it is positive. And the unit for frequency is just per second, because time is second, then we have -1 there. So per second, or some of you are used to as, but you need to know this. It's the one which you'll be using most of the time in physics. So this, everything you need to know as for now. So let me just give you some of the questions that you are going to answer, so that you're going to drop your solutions in my inbox. So the first thing you're going to find, so I'm going to say the question. I'm going to say find the dimension and units of the following quantities. So number 1, you're going to find the dimension for momentum and its units. So momentum and its units. Then B, you're going to find the units and the dimensions for work or energy. These are just the same dimension and units. Then the last but not the least, you're going to find pressure. You're going to find the pressure, its dimension and its units. So to be very good with you, so that I know most of you start complaining you don't know the formula for this. So I'm going to give you the formulas, but don't expect for you to be given formulas in exam. So for momentum is given by mass. So the formula is mass multiplied by velocity. Then work, I know most of you know that it is a topic in grade 12. So there is force multiplied by distance, and the pressure is given by force over area. So go ahead and find the units and the dimensions. So make sure you drop your answers in the